Hello, my name is Evelyn and welcome back to the review of Trigonometry AB. Today I'll be teaching you how to use the Pythagorean trigonometry identity. So as a review, a trigonometry identity is an equation that involves trigonometric function and is true for every single value substitute for the variable, assuming that both sides are defined by that value. You'll find that trigonometric identity are especially useful for simplifying trigonometric expression. So the most common trigonometric identity are involved the Pythagorean trigonometry identity. So the Pythagorean identity has three types. The first one is tangent square of theta plus 1 equals secant square of theta. The second one is sine square of theta plus cosine square of theta equal 1. The third one is cotangent square of theta plus 1 equals cosecant square of theta. So to explain sine square theta plus cosine square theta equal 1, you have to look on a unit circle. So remember the coordinates of the unit circle is cosine, comma, sine. So since the leg of the rectangle is in the unit circle have the value of sine theta and cosine theta, the Pythagorean theorem can be used to obtain sine square theta plus cosine square theta equal 1. So to explain tangent square of theta plus 1 equals secant square of theta, remember that sine square of theta plus cosine square of theta equal 1 is the fundamental to understanding this. So to understand, remember that the quotient identity of tangent is equal to sine over cosine. So here we can see the substitution and calculation that give us tangent of square of theta plus 1 equals secant square of theta. Similar goes to cosine square of theta plus 1 equals cosecant square of theta. You can see how it goes with the quotient identity of cotangent equal cosine over sine. So here I'll be teaching you two examples on how you can use the Pythagorean theorem. So the first one is using how to use the Pythagorean identities to find missing trigonometric values. So here we have the unit circle to guide us, and the question asks, find tangent theta in the range of negative pi over 2 and 0 if cosine theta is equal to 1/2. So here's the range of the circle they're asking. Since the range is negative, the unit circle goes clockwise, and that's how the range is right there. So in order to find tangent of theta, you must find sine of theta, because remember that the quotient identity of tangent of theta is equal to sine theta over cosine theta. So to find sine theta, you use the Pythagorean identity of sine square of theta plus cosine square of theta equal to 1. You plug in for cosine 1/2 square and do algebra equation to get 1 over 4, and you minus both sine by 1/4, and you get sine square of theta equal to 3/4. So in order to eliminate the square sign, you have to square root both sides. Is equal to plus or minus 3/4, or sine theta equal to plus or minus square root 3 over 2. So remember that the range that they're asking is from negative pi over 2 to 0. That's the determinant factor to know whether it will be negative or positive square root of 3 over 2. So see that the range is from negative pi over 2 to 0. You can see that sine in this area is all negative. So our answer would be sine theta equal to negative square root of 3 over 2. So here, remember the quotient identity of tangent is equal to sine over cosine. So we just need to plug in For our equation, sine is equal to negative square root of 3 over 2, and cosine is 1/2. That is similar to negative square root of 3 over 2 times 2 over 1. So you minus both the 2 and you get negative square root 3. Square root of 3. So the second example is how to use Pythagorean identity to simplify trigonometry expression. So the question asks, how do you simplify sine theta cosine square of theta minus sine theta? So that's the original equation. So in order to simplify, first you have to do algebra, factor both sides, so you get sine of theta equal to cosine square of theta minus 1. So the equation for the Pythagorean identity is sine square of theta plus cosine square of theta is equal to 1. So in order to find sine square of theta, you must do 1 minus cosine square of theta. But then here's opposite. So in order to get 1 minus cosine square of theta, you times everything by negative 1. And that's how, and you get negative sine of theta times 1 minus cosine square of theta. And using the Pythagorean identity, you simplify it to negative sine of theta times sine square root of theta. You time them together and you get negative sine 3 to the power of 3 theta. That's your answer. Thank you for listening.